Well, prynhawn da. Good afternoon, everybody. I'm Lloyd, and I'm a senior immersive producer at Atkins, SMEs, Lavalin. So I think we've got the largest dedicated VR team within the construction industry, and I guess we would be considered now a small indie games development, because in essence, you've actually walked into a games conference. So the talk I was asked really to just talk about how Atkins, SMEs, Lavalin is implementing new digital technologies, and how some of our design processes are being disrupted, changed, and improved. First of all, what is immersive and interactive technology? So it's something you can have an effect over, and something which draws you in or you're embedded into. These are the kind of two key principles we work from. So there's three interactive immersive types we deal with, if you like. One is what's known as windows on the world, and that's a fairly straightforward one. Your computer is a window onto a world, looking at a screen, a frame into a new 2D world. Virtual reality, which I guess most of you have heard that word by now and have some kind of an idea what it is using specific head-mounted displays and controllers, and you're fully embedded in a complete digital world. So that wraps around your vision, and you're fully embedded into that world. The third one we use, I haven't got anything to kind of show that today, but this is beginning to become quite an important technology, which is augmented reality. That's using a mobile or head-mounted hardware, and it overlays or composites images on top of a real world. Now, we have done a couple of those projects. I don't have anything here, but that is the next big technology going forward, and we'll talk a little bit about that maybe at the end. So what's windows on the world? Quite simply, it's that frame. It's like a proscenium arch which you look through onto a world. It's like a window onto a new world. And most of our kind of your desktop applications and your things like video games, we've got some flight sim stuff here. That's a simple window onto the world. But it has the level of interactivity, and it has a certain level of immersion as you're going forward. The next one then is virtual reality. So that's a next level of immersion. It plays on our 3D perception, and it's a complete wraparound world. And then the third one then, augmented reality. You have the HoloLens here. And what that essentially does is drop or overlay like a composite. It's a bit like Photoshop, if you like, onto the world. So it mixes the real world and an image which you project onto it. So it augments the real world, really. So I think going forward, these are going to be the kind of the core technology, especially on things like construction sites. There could be a big movement going forward with those. So why are we now actually using it? If you've noticed, why are we having this conference? Why all of a sudden are we actually using these bits and pieces of technology? So we're able to use these tools due to a number of revolutionary developments in essentially an unconnected industry, which is video games. Over the past 5 years, the technology has become cost-effective and accessible due to these revolutionary changes. So there's a lesson there for us really to keep an eye, even as engineers and architects, to keep an eye at other industries to see how that industry can be, those ideas and movements can be brought into our own industry. So when my background is an architecture school dropout, then I worked in the video games industry for 20 years, actually building environments. And 20 years ago, when I started in the video games industry, if you wanted to build a video game, the coding team, and this is just the coding team, this is not the creative team, this is just the coding team, you'd require graphics and rendering technology team, which usually be 1 or 2 people, highly skilled. The early ones would have been at PhD level and above, because there's a lot of complex maths involved, and there wasn't the YouTube channels and the books. You had to have gone to done mathematics pretty much to do that. Animation and environment technology team, pretty much the same level of skills. Gameplay programming, scripting, a little bit lower. Now that would be kind of the entry point for a lot of people. Then you'd have tools. So tools that you develop, digital tools for artists like myself to work with to get things into the game. You'd have audio technology team, physics simulators. So you'd be looking at people with physics PhDs and could code, very rare. Character response and AI. These, all of these skill base were difficult to find, and they were people who are very, very highly paid to do this kind of things. And even things like networks and multiplayer teams. And also, it wasn't available off the shelf. You had to build this yourself. So the first thing was the innovation in software technology. So during the early 2000s, a small number of companies realized that game studios were all generating exactly the same code. So physics does not change with each platform and game. There are certain consistencies. Microsoft introduced something called XNA as a framework for enabling faster development. But a small company from Denmark understood what the market wanted, which was easy access to making games. They understood that what people really wanted to do wasn't necessarily deal with the technology. They wanted to make games. In general now, to make a modern video game only requires gameplay coders and a creative team. Now, you can't do that for every game, so the biggest game, you still need some of that talent. But now, look at the difference. You're taking out all the very, very expensive talent. They've taken all of that out. They put it into one product, and they sell it now. And by the way, you can download it for free to start the learning process on it. And that was a key as well, you download it for free. So it was Unity by Unity Technologies. This software has essentially revolutionized the game industry and allowed companies like Atkins then to even consider using this tool. So one was software, the other one's hardware. But in 2010, Palmer Luckey, and you can Google Palmer Luckey to see his history, he's got quite a colorful history, designed the first prototype of the Oculus Rift. And he reintroduced the idea of VR, because VR had gone slightly out of fashion. It was too expensive. It made you sick. But he reintroduced it. And then in 2013, Valve, Half-Life people, they discovered a new breakthrough in the displays. And this allowed then to have a lag-free display, which is critical. So these were little technical achievements that were being kind of put together. And by 2014, Valve showed their Steam site product, and that was a precursor of both consumer headsets released in 2016. So the commercial VR we work with now has only been going since 2016. The consequence of that is, as an engineering company now, Atkins has to start hiring people that are not necessarily trained as engineers. And this is now a challenge for us. How do we find staff to actually fulfill these positions? So we're hiring now people like technical artists. Now, I'm a technical artist. I started off as an artist, then learned to program, do technical art teams. So I work with APIs and Python scripting. Programmers with video games production skills. And then designers with UI and design experience for user experience. Then also now, I'm moving now more towards the kind of the production side. So we're looking now for producers with programming, creative, and business skills to actually drive this business forward. But one of the key things ideally what we would like is to see engineers with these skills and architects with these skills. Because at the end of the day, we're still building buildings. Yeah? We are not video games companies, we're still building buildings. But that's the challenge for us now. So what I'm going to do now for the rest of however much I've got left is show you some work that we're doing. Yeah? Okay. So that's Cockwood Harbour. Oh, hey, there we go. So what you've got then is, so this is as it was flooding. If you just see in the corners there flooding. And so this is the interactive bit. So what we can do then is we can kind of show, and that's very simply just a plane going up and down that we put a kind of a water texture on. So the proposed works then were putting walls around here. But what you can then do, and this was designed to run as a kiosk. So you can go into it at any point and look at it. Now, of course, this is how we used to do it. And that is pretty meaningless to most people, to be honest with you, because they can't read it. And you can go through it, but it's kind of important to be there because some people want to see it. But actually, being able to move around and have a look at it here is much more important. Because one of the things is people are concerned with these baskets here, that maybe what would happen to these baskets and whether they'd be able to see from the pub. So from here, you can very clearly see what's going on. So that was one of the first projects we did, and we had the Environment Agency. So this was designed for public consultation, but we had the Environment Agency in for what we call a tech lab, where we show a lot of the technologies and stuff like that. And they told us that they were now using this for site orientation. So it's because you could go to, somebody's coming on site, you could go to the position there and say, well, what's happening here is, you know, there's some samples here. You go to, say, this one. There you go. We're going to be putting a gate like that in there. So you could explain to people and clearly communicate to people what was going on. And so it was a surprise to us, but it was also, we felt, a very positive move that they were then using something used for public consultation, and they were using it for site orientation. It's all using the same but different bits and pieces of software. Now this is from about 1.5 years ago. So we've moved on a little bit with visualization now. I'll show you a video that we've just done of a viz, and you can compare it. But one of the things I want to show you in this is one of the things in terms of design. Where am I here? So I just want to show you a principle where you think sometimes, well, VR is just for pretty things or maybe walking around. We use it also for, as an integral part of the design process. And one of the things we do is we found some filters we could put on the camera to simulate some visual disabilities. So what we did is just put that box in there just to illustrate to people what could be done with this. And so deuteranopia is a form of color blindness. And that's how severe it is. But one of the things when you look at that is you can be very aware, you have to be quite sensitive to where you put some signs. Because if you put that sign against wood, it's great, like us, or whoever, maybe there are people who have color blindness. It's great if you can see that color. If you can't see that color, it's a problem. And when you're doing public works development, this can be quite an important issue, because when you look at it as a percentage, I think something like 1% of the population suffers from this. That could be quite big, especially in an emergency, could go to a real problem. The other one, tritanopia, which I think my dad has this, I think, which is green and blue. So certain colours still work quite well, but certain ones don't. The yellows are done pink, and that's a problem. But the other one was quite interesting, is when we were talking as a group about this, there was a gentleman who works in transport with us across there, and he was listening in a lot, and I'd seen him walking around the place with a white stick. And he came and talked to us, and he described his disability. And what we were able to do is to work with him and try and capture his disability. And this is what he sees. That's what he sees. And when you're in VR, that's a lot more potent. But it also means that we are beginning to get a better idea of maybe visual disability. And when you're talking about an aging population, this is potentially quite important. We've talked to transport potentially about doing some apps around this. So these kind of things are quite important. Now, in terms of the level we're at in visualization, this is a quick video. So this is now all real time. I can go around the real time, but this is actually a video. So in terms of what's happening with pre-rendered 3D and what's happening with real time, we're almost now getting to the point. So that's internal. So we're almost getting to the point now where we begin to get the lights looking quite good. And this is very important when you're trying to define space, especially with architects. So these are the kind of areas and ideas that we're kind of looking at. So what we're trying to do is get that quality of the light. So if anybody's been in VR, you get a good spatial sense. If you add the lighting on top, you get even more of the spatial sense. So here we go. That's the level we're getting now for visualization.